Hello everyone and welcome to the fifth episode about game development. And in this one we'll be doing things a little bit differently because I made a mistake with the video. I deleted it basically permanently from my PC because I recorded the fourth and the fifth episode in a row. And when I edited the fourth episode, I deleted the fifth episode file, right? So yeah, I basically lost the footage for this one. So I think that to keep things more or less real and in this theme of live coding, today we'll be doing code review session, right? Because yesterday I recorded an episode for the bucket list, like I told you I was going to do, and I actually faced a few challenges, and they were quite interesting, right? They were very, very interesting. And I think that it is very useful to go through all of them and explain why I did things the way I did. I hope I remember all of them. And yeah, so I usually commit the result of each live coding session I upload to YouTube to a private repo, and this was the result of the fifth session. So I'm not going to explain this right now. Where do I begin? I probably can start by taking a look at the temp demo. So here I created a temporary demo just to test things out for now, and I can use it to explain to you what I did, right? So I declared it's in a similar fashion to what we have with the list. So as you remembered, I had this declare list macro that declares me a list with this name and this type. And I had a similar thing for the bucket itself and for the bucket list. So here we are just declaring a bucket of integers, and here we are declaring a bucket list of floats, right? And here we start the temporary demo. Here I define int bucket variable, and this is just test code, and I'm going to explain you what this does in a few seconds. But here I just declare the variable. I just occupy some slots. I'm going to explain you how this works, and then I traverse through all of the occupied slots in this int bucket, and I print the data, and then I print the index of that data. Okay. Then I declare my float bucket list. I zero initialize it, and then I append 312 floats to it. Here I traverse the bucket list with my for each macro, and I just print the current float. And at the end, I calculate the amount of buckets we are using, and I just print the each and every single one of the buckets as a fixed capacity. I just print that capacity, and then I print the amount of buckets we currently have. Okay, so if I run this code, I compile and run, what we are going to see is this. So this is the bucket demo. As you can see here, right, I've placed the number 42 in slot number 0 and the number 84 in slot number 3. And how do I determine if a specific slot is occupied or not, right? So I have this word, right? And this word has 64, 30, and this word has either 32 or 64 bits usually, or another random number of bits if the hardware architecture is a bit more exotic. But it generally has 32 or 64 bits, and each one of those bits represents, or actually tells us if the current that specific slot is occupied or not. So the bit position is basically it indicates if the slot at that position is occupied or not. So a 1 is occupied, a 0 is not occupied. Okay, and the bucket implementation itself, I basically did this because I think this is reasonable in my opinion, right? So I basically say that the bucket capacity is always going to be equal to the number of bits in the word, in the hardware words that we are running the program on, right? Because if you are running on a 64-bit machine, you probably have more RAM than if you were running on a 32-bit machine, probably, right? So it is safe to assume you can, or you want, or whatever, you can have larger buckets, right? And each bucket is going to, in this case, I'm running on a 64-bit machine, so each bucket is going to contain 64 different slots. So each slot stores an element by value, right? And with a single 64-bit word, we can store all of the occupied flags. So it's very compact, right? It's very compact to do this stuff. Okay, so yeah, I just do that. And then we have this bucket for each occupied macro. I think I'm going to remove that in this episode, right? Because we have this occupied and this free macro, and I don't like this. And why did I need to create that? Because I use the occupied in the bucket list for each, and I need to use the free in the bucket list add. So yeah, that was what I did yesterday, but I think I'm going to remove that today. But in any case, I have this bucket for each occupied and this bucket for each macro free, and they do the same thing. The only difference is this if. So in this if, we check if the current bit for that index is a 1, and if it is a 0, we ignore it. If it is a 1, we give that iteration to the user. So we just inject the user code here, right? And here we do the inverse. So if it is occupied, then we ignore it. Otherwise, we give that to the user. Okay. So yeah, let me keep explaining this. So here is very simple. Just traverse through all of the occupied slots in a bucket. Here we define the float bucket list, and the float bucket list is also very simple. Here we have the bucket list generic struct that contains the options for the bucket list, and it's the same thing we did with the list. So super simple, just some copy paste code, right? It has an allocator, so each bucket list may also have an optional allocator. It's going to have a default one, but you can provide a specific allocator if you want to use a specific allocator. Then the declare bucket list macro is also very simple. We just declare a bucket for that type, and then we declare a list of the bucket we just declared, and we give it this name. And then for the bucket list itself, we use the options and the list of buckets, right? We just call it buckets for that list of buckets. Then we have this macro, a bucket list add, that basically just adds an element to the first empty slot it finds, right? And in this macro is also very simple. We just traverse. So this has two nested for each loops for different types of collections, right? So we traverse the external loop traverses through all of the buckets because the buckets are stored in a linked list. And then the internal loop traverses through all of the free slots inside the bucket. Here we pass the buckets that are inside the bucket list, and here we just pass the iterator because the iterator at this point contains a pointer to the buckets. Okay, and the iterator inside here contains a pointer to the slot itself, right? We must not forget that. The iterator at each level of the loop contains the current loop iteration data pointer. Okay. Here we have this it container. I'm going to explain why I needed this, but we can move forward. So we just assign the element to the current value of the iterator. We mark we mark it as occupied, right? And here this was a problem I found yesterday. Here we need to explicitly cast this one to a uint pointer, because if you don't specify the type of a number of an integer number in C, it is automatically cast to an integer by the C compiler. So here we need to be careful because this one needs to be the same amount of bits that are inside of a word. Because if we didn't add this cast, then we could only occupy 32 slots in each bucket because this one would only be 32 bits, right? So if we cast it to 64-bit integer, then this index can actually shift it properly, right? This was a problem I found yesterday because I was using more buckets than I wanted, and I was a bit confused, and then I realized, oh, this one is actually integer, I need to cast it to a word, right? And then we just have this go-to, it's simple. We go to the end loop and when we find a free slot, so we don't allocate more stuff, right? It's very simple. Here we just pass the bucket list allocator to the list allocator, right? So we need to do this because if I define a custom allocator, or if I define an optional allocator for my bucket list, I want all of the data structures that the bucket list uses to also use that allocator, right? So in this case, I give my bucket list options allocator back to the list that it contains. Then I define zero initialize the bucket. Then I append that bucket to my list. Simple. Then since I know that this bucket is completely zero initialized, I know that all slots are free, so I can simply append my element to the first slot, and I mark the first slot as occupied, right? And then everything I needed has been done. Okay, so the list add is a simple implementation. Then the bucket list for each is even simpler, right? Is even simpler because here we just traverse through all of the nodes in the list, so all of the buckets. Here the iterator basically points to the bucket, and we just check. Here is optimization. I explain it afterwards, but so iterator is buckets, and I just traverse to all of the occupied buckets, all of the occupied slots in this bucket, and I just pass the code to this macro, and I just inject the code in an appropriate place. And here is an optimization because this is one of the great benefits of a bucket list, and this is why I want to use this data structure. Because in a game, sometimes you have specific storages, specific collections that are going to allocate and deallocate, so add and remove elements very frequently. So I would expect in those cases to have some nodes, so the few last nodes or many nodes at the end of the bucket list are most likely going to be completely empty, right? Because if I add and remove a lot of elements and I use this function to add them, so if I use this function to add them, so this function picks always the first empty slot, right? I expect to have a lot of empty buckets at the end of the list, right? And how do I check if these 64 elements are being used or not? I can simply use a single if, because this is a single word, so we can check for 0 with a single machine instruction, right? So I can, with a single machine instruction, I can skip 64 elements at a time. So if a bucket is completely free, so if the 64 elements in a bucket are not being used anywhere, I just skip it entirely, right? So this is extremely fast, right? And this is why I want to use a bucket list, because it's very optimal for the situations where we are constantly adding and removing stuff from it, right? So when we add a lot of stuff, the bucket list grows, and if we remove a lot of stuff, then the bucket list remains with its size, but the few last blocks are going to be completely empty, and we just ignore them with a single machine instruction, so it's almost free, right? It's almost free. Yeah, so this is this thing. And I think I've explained all of it. So in this case, I'm allocating 312 floats, and to allocate 312 floats, taking into consideration that each bucket stores 64 floats, I basically need 5 buckets, right? I basically need 5 buckets, and if I compile and run, as you can see, I needed 5 buckets to store 312 floats. So if I change this, let's say to, I don't know, 72, this is only going to need 12 buckets, 2 buckets, sorry. This is only going to need 2 buckets because 64 plus 64 is 128, and 72 is less than 128. Let's say if I need 64 floats exactly, then I'm going to only use a single bucket, as you can see. So I was able to store 64 buckets, 64 floats in a single bucket. So only one allocation required, right? So I only needed to call malloc once. And yeah, that's basically the behavior. So if I say like, I don't know, like 1009, this is going to use 16 buckets. So as you can see, yeah, this is quite efficient, right? I could use a single allocation, but this data structure allows me to have a very specific use case that I want to use in my game, and it's reasonably efficient for what I want to use it, right? And it has a very good property that I already explained. Okay, so let me put this back to, I don't know, 65 or something, right? So we allocate 2 buckets and this doesn't pollute too much the console. Okay, so now I'm going to explain you the last thing I had to improve in my for each macros, which was this stuff, this eat container. So why did I need this eat container, right? This is something that I had some trouble to debug, but I can explain it to you by doing this. So I can simply, well, this is on GitHub, so I can remove it, I don't care. So if I remove this and I remove this, these macros are no longer going to work. Oh, I actually need to go back to my old code because previously, alright, so I cannot simply just remove it. Previously I was using these, right? So this was, I think I called it a node previously, so I can say this is a node, okay? I don't need to reformat, I'm going to just revert all of the changes, not important. And here I was using the bucket itself, so I can simply say bucket, and I can remove that. Okay, and here the same thing. Okay, and this is now complaining about something. Oh, here it's not it container, it's going to be I can do something. What can I do? Let me think about it. So I can do so this is here I can basically declare a type of bucket list, and I can declare it as being the same type of buckets dot data, right? And this is going to be my I can call it the P for now, right? It's just a demonstration code. So if I give this the P name, and this is going to be that, this is going to be actually a pointer, and this is going to be equal to the current iterator. Okay, and I think I don't need anything else. Yes, I think that's all. And this is complaining about something. It's complaining. Oh, it's already. Oh, wait, I think I forgot. Where do I need the semicolon? Somewhere I forgot it, probably. Let me check my list for each. So now I have semicolon. Let me check where the semicolon is missing. So let me just copy this code and see. Node is equal to node link. Where? Oh, because I forgot here, type of, right? Yeah, type of. So I need to do type of. And this still complains because I forgot how to use this. Let me check what I had previously. I'm just trying to do what I had previously. So I can just copy this code, right, and use it. It's probably easier than changing it manually. So this is what I had previously for my list for each. Okay, so this is still complain. Oh, okay. Yeah, I probably had some type of whatever. Okay, so this is not going to work. And why is this not going to work? So this is why I took some time to debug this yesterday, because this is already a macro expansion getting out of hand. But this is what I told you guys yesterday, because this is what I told you guys yesterday because these macros, they are very hard to debug, but once I'm sure they work and they never break, then they are very, very easy and very pleasing to work with, right? So they are very, very substantial. They kind of free up a lot of my development time since I'm using C, right? Because as you can see here, it's now super easy to declare a bucket list, right? I can simply say declare bucket list, I say the type, I say the name, and then I can just add elements and traverse elements, right? The content of the macro itself, it's getting very complicated. The expansion of it is getting very complicated, but overall, the usage of this API is very good, right? And these macros, as long as they are properly programmed, right, properly they have the correct code, they are never going to break, right? They are never going to break because they are type safe. Because here I'm using the type of operator, right? Because since I'm using the type of operator, I have the guarantee that they are never going to break, because this macro is always going to declare the variables with the correct type, right? So let's just debug the problem together, and I'm going to explain you why I needed that it container variable. So let me do what I did yesterday, which was to format this a little bit better. Okay, so this is a better example of what we want, right? So if you remember correctly, so the it variable is implicit and should always contain, by definition, a pointer to the current data that we have in this current iteration, right? And here we are saying, where is it? It's inside here. Here we are saying that the bucket is basically we are checking this if, right? If the bucket at that specific bit is flagged, then we ignore it, right? But here we are using the correct value, right? We are saying, oh, the bucket, the specific bucket that we are iterating as this occupied flag. But we must not forget that this bucket is a preprocessor token, and this preprocessor token is going to be textually replaced, right? And since it's being textually replaced, it's being replaced by the wrong thing, right? Because this bucket, if we go here, this bucket is being replaced by it, and it is not what we want. It is not what we want, right? It is not what we want, because it inside this for loop is going to mean something else, right? Because it outside of it means bucket, and it inside of it means float, right? Pointer to float and pointer to bucket. So this it variable, one of the problems of having this variable implicit is that its meaning is going to change depending on where we have it, right? It allows me to have very terse and very easy to understand code, but or maybe not that easy to understand if you're not familiar with this kind of notation, but at least very terse code. But we need to be careful because it has different meanings whenever, depending on where it is being used, right? So it in here means pointer to bucket, and it inside of this loop means floats. And here we are textually replacing this value, so this string it, we are replacing it also here. So this bucket is not going to be the bucket, it's going to be the pointer to float, right? Because it's going to be textually replaced. So that's one of the problems of C preprocessor macros, is that it is not aware of variables, just replace texts, right? So one good solution, one very good solution I found that is also type safe, right? It allows us to have type safety, is to use, let me now revert all of these changes. I can discard changes. One of the solutions I found, well, I can also discard this, it doesn't matter. Let me delete this, and here I can already remove that because you already know, you are already familiar with the problem. This is some trouble. Let me just reopen it. Okay, so the solution I found is to have another implicit variable, right? So now we have two implicit variables. We have it that points to the current iteration data, and we have it container that is also an implicit variable in our for each loops that points to the container that contains that data. And this is an actual variable inside our loop because we are defining it being the same type of the container. And we have this both in the bucket for each, and we have it also in the list for each, right? We have the container in here. So by declaring or by defining this implicit it container variable and using it everywhere else in the macro, we no longer have the problem of textually replacing something that shouldn't be replaced, because this is the very first thing we do. We define the container, we replace it with the correct code, right? We replace it textually with the preprocessor token that currently holds the correct code, and only then we define the iterator, right? So here, this actually, I found a bug, this actually, oh no, this is correct, right? Yeah, this is correct. First we define the container and then the iterator. Because after this, the iterator is going to probably blow up the text, right? Or actually invalidate the text that was passed here. And this is the fix, right? And this is also type safe. It works. You can have nested stuff. I didn't test it, but let me test it if I can. I don't know. Let me reduce the amount of floats. I'm going to say 16 or something like that, and I can have, for example, two nested loops here, and here this is going to be inner, and this is going to be the outer loop. And if this is correct, the it container variable should also shadow properly, right? So this is the same question we had here at the very beginning when we defined the list macro. Here the it variable is shadowing properly, and here I expect the it container variable to also shadow properly. But we can test it, right? We can just test it and run it. Oh, let me do something. So here I'm going to add a printf. So this is going to be inner space. This is just going to print the float itself, and here I'm going to print a simple new line, and this is also going to have a new line in here, right? So it's probably easier to read. So let me reduce the amount of floats as well. I don't want 16, let me use just, I don't know, 6, so it's easier to read. Okay, so as you can see, we are looping it correctly. So this is floats list. So this is the first one. Where is it? This is the first one. This is the bucket. But here we are printing outer, and then we are printing inner, outer, inner, outer. Oh, this is strange. Because I don't know why I'm printing outer first. Because so this code is being called first for some reason. So all of this code, or is this some sort of problem with buffer? Oh, okay. Oh, I see. I'm actually dumb because I need a new line in here. So this is not, well, yeah, I need a new line in here. yeah, whatever. So it was actually on the same line, right? So we have float bucket list. This is printing the inner elements, then outer, inner, outer, and so on and so forth. And this is properly doing things, right? And let me do something interesting, right? For every iteration we have, well, this is probably going to generate an infinite loop. I wanted to append some elements, but I don't know, I can say something like if the current value of it is less than 3, I can reappend it. I can reappend it to the list, and this is going to generate some interesting code, right? So, oh, duplicate. Okay, so this is another problem I need to fix later, because I had this out yesterday. I didn't know if I could have this label here, and apparently I cannot have duplicate labels. So yeah, this is going to be one easy way to fix this is to have a variable, say I can fix this right now, right? So I can simply say oh, this is improperly indented, but I can say if this is breaking and this is false, I can simply say then this. So I can say, oh, but here I need, yeah, I can fix this in another episode, right? This is going to be a to do fix break, because in this episode I already want to do something else. I want to change the implementation of bucket list a little bit. But basically my idea is to define a boolean variables called breaking or something like that, and each one of these for each macro needs to handle its own breaking variable, and we just break out of the loops using a variable instead of a goto macro, a goto statement, right? It's easy to fix it, but okay. So but the code itself, it's working, right? So it's working. Okay, and I can probably revert this later, or actually let me revert it now, because I'm going to start doing some changes. So I need to revert that. Okay, and well, let me not do this, because let me just pull the changes from main. Yeah, whatever. Let me clean all of this and pull from main. Okay, so this is not going to be, yeah, this is still going to be 5. Yeah, this is still going to be 5, but let me say 5.1 or something like that. Okay, so now I want to do a little improvement in this episode, so I just don't code review, guys. Yeah, so I just don't do a code review. I also want to implement stuff. But I think overall I explained you more or less my reasoning behind the bucket list. I explained to you why I want to use it. I explained to you the benefits. I explained to you the challenges I faced while implementing it. And I still have this to do fix break, right? I want to fix the break. And now I'm going to change the implementation, because I don't want actually to have this bucket being a public thing. Okay, so I don't really want the user to be aware of the bucket. I want the amount of slots to be more or less private, like in airports. And I don't want to have these two different macros, right? So I basically want to turn this into a private in air quotes field, private declaration, because I don't like these two macros, right? I want to just inline them with my own code. So the change I'm going to do is going to be very simple. I'm just going to remove this from here. I'm going to paste it here. So I just need to do that and add a new thing in here. Okay, so what am I going to call this? I don't know. Maybe I can call it, let me remove this from here. Maybe I can call it with an underscore in front of it, or I can call it, this is the base package, so I can say base bucket capacity. Well, I can call, well, whatever, I can change the names later, so I'm just going to keep the same name, bucket capacity, for now. The type name for this is going to be, I can say the same type name I had previously, and that type name was, what was it? It was this, so I can just reuse it, it's not a problem. Okay, what am I doing? Okay, so then I can basically not add this, right? So that's the why I want to remove bucket from the public API. I can simply say, so I can simply copy this code, I can simply copy that code and put it in the occupied thingy here, and let me just think about it for now. So am I going to need this? I no longer need this it container. I no longer need this int container because this is no longer being textually replaced. This is just now inlined. This iterator is correct. It is in fact correct. So we redefine the iterator. Then we have it index. Oh, I actually need it. Yeah, we actually need the it container because, as you can see, this iterator is now, it now means something else, and I cannot use it inside of here, so I actually need this code. And this it container is now being assigned the current iterator. Okay, so this is like that, and here I'm traversing to all of the occupied slots. So this is the code. So if this is 1, well, yeah, if this is 0, it's, yeah, okay. So since this is a variable, I no longer need this parenthesis because this is a variable in here. Okay, so I no longer need to do any of this. What else? So this needs to be there, this needs to be there, and then we have the not. Okay, so I think that's the entire implementation. Right, that's just a simple copy paste, super simple. And here, do I still need this? I may still need it because here the code may not use it, right? So I still need to void it at the end. Okay, so that was easy to inline. I can just remove that. And now to iterate for through the free elements, I can do a similar thing, and I can basically just replace. Oh yeah, this code is going to be replaced there, and I need to replace. I can put this here first, okay, and I can. Oh, that's not what I wanted. I need to do this. So here I define the container, and this container is going to be assigned the current value of the iterator. Okay. Well, here. Oh yeah, because, well, this is not the type of bucket. This is actually the current type of the iterator, right? I did the same mistake here, I think. Yeah, this is the current type of the iterator, not the current type of bucket, because bucket does not exist, right? The value of bucket. And here, the same stuff. I need to put iterator, not bucket, right? Because the iterator is the variable we want to use. And I don't think I'm using bucket anywhere else. I'm just using iterator. Okay, so this is actually correct now. Here I want to do a similar thing, so I need to remove bucket and put iterator here. Then I traverse using it index. This is the bucket capacity. Here I don't need this stuff. Same thing here. Okay, that's correct, that's all correct. Then I put the code of the user. But the code of the user is actually this stuff. So I can simply yoink that and put it here. So yeah, I can now remove these codes. And since I already know what I want to use, well, I can, yeah, whatever. Well, I could probably, where is this being used? Here, so I can say it slots at the specific index is equal to the element, and here we need parentheses because this is being textually replaced, so I no longer need this line. And then I mark the container occupied flag as being occupied. Okay, so I think this is now everything. Okay, let me just format this. And I think this should in theory have the same behavior, so I can remove this code. And now I no longer have the concept of a bucket, right? And since I don't have the concept of a bucket, I cannot use this macro. This no longer exists. Right, so I'm no longer going to be able to manually assign these flags and whatever because it's not exposed to the user. And yeah, I think this should all work the same way it worked previously, but let's test it. Wait, so base 91 unused variable. We have an unused variable somewhere. Oh yeah, because it is in fact correct because we no longer need this. And since we no longer need that, and we are not actually replacing it, then we no longer need to assign the iterator to another variable. We can simply say this, and this is going to, oh, I can simply say that actually, and this is going to simplify things a lot. Okay, so we have it, and this is already going to be the bucket. Okay, I think now this should compile. Let's see, and it does in fact compile, and it works the same way it worked previously, as you can see. So we have I can call it bucket list demo, and I can already call it bucket list demo, right? So this is now what we wanted, and I can place my bucket list demo below the list demo. I can actually move it to the correct place. So this should be here, right? This should be here. And let me stress test this. So let me say I want 50,000 floats. 50,000 floats. This is going to be very slow, but bear with me, just a stress test. So this is in fact taking some time. Okay, so my bucket now has 782 so my bucket list has 782 buckets, so this is probably correct. So let me actually, well, we can print bucket list capacity, which is going to be equal to the buckets count times the bucket capacity, right? And let me not print this for now because this is just slows down the code very much, and it should be almost, well, it's still a bit slow, but whatever. Yeah, so my bucket list has capacity for 50,048 floats, which is basically matches this. So right, yeah, and yeah, we can actually add 50,000 floats easily, right? So this is not going to be a problem. Okay, so let me reduce this back to 300, well, let me say 68, right? 68. Well, I could actually use bucket capacity plus 1, so it forces it to allocate 2 buckets. And now this is almost instant. Yeah, so the bucket capacity is 64, the bucket count is 2, and the bucket list capacity is 128. Okay, so this is working. I probably want to add a small demonstration that we can have nested loops in here. So I can have the outer loop, and this is also going to be that. I can have an inner loop. To the outer loop, I'm going to, so I can say buckets list adds. To the outer loop, I can add just 2 elements, 1 and 2, and I can add something similar to the inner loop, so I can say 100 and 200, and here I can just say this, and this needs to be replicated, and here I can simply say inner, and I can simply say inner, and this is going to be outer, and this is going to be the outer loop. Actually, I may want to use different types, so the user is aware it can have nested loops with different types. What can I use here? I don't know. I can use longs. I haven't used longs, I think, in the demo, so I can use a long, and this is going to be long, and this is going to be that, and the inner is now going to be an LD actually, right? So we are going to print longs, and then we are going to print floats, and this is going to demonstrate that we can have nested list, bucket list for each. Oh, I cannot type for each. Right, so nested list for each, and this should also work. Or where is it complaining? Oh, because yeah, we need to fix this the default. Okay, so I cannot have this demo right now. So this is still not working. I need to add this behavior later, right? So, and I'm probably going to fix that in next episode. Okay, but that's basically the implementation of bucket list I1. So we still did some live coding today. And yep, I think that's all for now. So yeah, I see you tomorrow.